Welcome to another episode of DLT's ContinuousX podcast, where we attempt to solve for X in the SDLC equation. My name is Rick Stewart, DLT's Chief Software Technologist, and joining me today, as always, is my co-host and colleague, Mike Bitzerka, Senior Sales Engineer for our Application Lifecycle Technologies. Today's guest is Clinton Herget, Principal Federal Solutions Engineer at Snyk. Snyk provides developer-first tooling along with best-in-class security intelligence that enables agencies to build security into a continuous development process. Perfect guest for the ContinuousX podcast. Welcome, Clinton.
Thank you, Rick. Glad to be here.
As our viewers know, this forum is a Q&A style, but what Clinton doesn't know is an incorrect answer will cost him an hour of discussion and explanation of DevSecOps to a 6-year-old. So answer carefully.
Fortunately, I feel like explaining DevSecOps at the 6-year-old level is part of my job anyway. So looking forward to it.
So there's got to be a risk then. How about an octogenarian?
Getting warmer there.
Okay, terrific. All right, so question number one. With the current administration's executive order on improving the nation's cybersecurity, does this lessen the risk of incidents and attacks in the software supply chain?
Well, hopefully it does over the long term. I think now we're in a period where we're finally paying attention to the right things and recognizing that, boy, software is a heck of a lot more complex now than it was 10 years ago, even 5 years ago. There's additional layers of the stack. What a software developer is doing on a day-to-day basis is very different. And what's needed are security solutions that take that complexity in that cloud-native world into account. And I think the executive order was a pretty clear admission that the way we've been securing applications up to this point no longer applies to the way software is being developed today. What's needed is that real paradigm shift, and obviously government and industry have to work together to bridge that gap in the meantime. I don't think that, just recognizing the issues certainly doesn't lessen the risk of attack in the short term, but the attention that's being paid to the problem, certainly getting the right tooling in place, but more than that, the right mindset when it comes to security is really what's necessary to start closing that gap, preventing some of those intrusions, especially around the software supply chain.
Yeah, I agree. I think the first step in any kind of resolution is identifying the problem. And with the problem being that lots of open source is being used, lots of third-party libraries and dependencies, that supply chain becomes critical because you don't know what you don't know.
Absolutely. And I just, having been a software developer for 20 plus years at this point and seeing that transition, it really used to much more be an act of construction, right? You're building these applications one line at a time, very lovingly. They're these big layered monoliths, deploying onto some kind of centralized, IT structure, everything built in-house, right? And that game doesn't play anymore, right? Everything's much more rapid. When you're deploying every few minutes instead of every few months, you need a different model for building these applications. And the model has become, hey, if I need a bit of functionality, I'm going to go out and find it, right? I'm going to find that Lego block, plug it into my app, and then be off to the races, right? So software today is more an act of assembly, right? It's like building IKEA furniture or Legos, or kind of take your pick. But what that means is the risk profile is different, right? The risk is inherent in all of those pieces coming in. And you very quickly run into this transitive dependency problem, right? Where I might be aware of the dependencies of my application, but what are the dependencies of those dependencies, and so on, especially when you get into things like containers, right? An application now is shipping with not just the proprietary code, not just the application, level dependencies, but all of the operating system libraries, the packages, the runtimes, the tooling, everything that would have previously been installed on the VM is now in the container. That's part of the application, unit of delivery. What can be done from that perspective, right? To even just get visibility into that bill of materials, let alone what does that imply from a security perspective, licensing, compliance, and everything else that, our federal agencies are rightly concerned with.
Yeah, and I think the problem's going to get worse because the applications are proliferating into microservices and smaller applications. So you, instead of the tens or hundreds of maybe legacy systems, you're going to have thousands of them all interacting.
Absolutely. And how do they interact with each other? And how are they deployed in a repeatable way? Because now not only is the all the OS stuff packaged with the application, so is the configuration, right? So is here are the cloud resources that I need to spin this up. Here's what the infrastructure looks like, the networking, the storage, the data tiers, right? That's all packaged together at the application level. And often those configurations are living in the repository, right, alongside the application code. So we have to consider that to also, be part of that bill of materials. And what all of those things have in common is it's now the developers addressing those, right? It's not infrastructure handed off to some kind of centralized team sitting in a NOC somewhere and plugging cables into a router. It's I'm writing lines in a YAML file that's defining who can see my application from the outside, what can it talk to, what ports are open, and all of that. Meaning that what used to be maybe network infrastructure security is now application security, right? And I think part of what the EO does is gets us over that initial paradigm shift of securing the application today is about a lot more than, say, static analysis, right? I mean, that's a useful component, but when you add in all of these other layers, you really need to shift from the idea that you can secure the output or the artifact of the build, and you have to shift toward how can you secure the process used to build that piece of software, right? With all the visibility that entails.
Yeah, and not to pick on our primary audience is a government sector, and not to pick on them on much because I know that they are trying to advance in security, but they're not always working on the build. There's going to be a developer build today, and maybe 10 of them today. They could be in they'd be lucky or happy to be on a 1 week, 2 week cycle. So I was kind of wondering what with the changes that we're trying to implement, and especially with like 0-day threats, by definition, we found out about this now. How do we handle this? Do you have any insights or advice that you can give to help address in the public sector these type of vulnerabilities and to get them to move into that more rapid development?
Yeah, absolutely. I mean, I think if you're chasing the speed at which you can secure what's coming out of the developer shop, you're never going to catch up, right? Because that's only going to get faster. It's only going to involve more and more layers and different kinds of aspects of that technical stack, right? So I think that's a losing battle. What you have to do is
shift that. Viewers have no hope?
No hope at all. It's burning down.
Well, that's it. That's a great episode. We'll end it here.
Exactly.
Day zero, not doomsday.
Yeah, okay.
Right. No, what I think that the paradigm shift that has to happen is shifting that responsibility for security into the build process itself and enabling developers to understand the implications of what they're doing, right? So that if you're finding out about a security issue when that application's already in production or when it's just about to go, over the fence and get deployed, it's already too late, right? Because that's already when the fix is most expensive. And I had a long career working for federal integrators and SIs, and the typical trajectory is we would spend 2-3 months putting a release together, throw that over the fence. They'd run an antiquated security tool against it and generate 1,100-page PDF. That you'd have to go through line by line to say, do I even understand what vulnerability this is calling out? Let alone what to do with it, let alone all of the refactoring and rework that I then have to do once I figure out that remediation, right?
Yeah.
And what if I could have that as part of my developer experience when I'm making those initial decisions and have that remediation advice directly at hand? So the identification of the vulnerability is almost, taken as a given, right? What I need to know as a developer is what's the action I can take to make this more secure. Maybe that's changing a line in my config. Maybe it's using a different base image for my container, upgrading a library, sanitizing a string so it doesn't become a SQL injection. But what if the identification of the vulnerability is packaged with, and here's what you can do about it, at the exact moment you're making that decision, right? And that's what we mean at Snyk by building securely as an alternative to securing the output of the build, because that's the only way we're going to keep up with, you rightly point out, the increased velocity that's just always going up exponentially, the move to Agile, to DevOps, to cloud services. We need to get into the developer experience, but in a way that has the right context at the right time so that we're providing solutions rather than just identifying problems.
And I think as a byproduct, you're actually teaching the development community about these exposures, these attacks, So it builds on itself to, be more hygienic over time.
Yeah, as a
Absolutely.
but
Well, I was going to say, I think specifically when you're talking about software supply chain attacks, right? That's something that I don't think even developers who are using these open source libraries don't necessarily understand the risk that entails, because I fundamentally can't see beyond that first level of dependencies, right? A couple of years ago, there was a very well published supply chain attack around a JavaScript library in use in thousands of applications called Event Stream, right? Everyone used Event Stream. There was nothing wrong with it, except that Event Stream had a dependency that was then abandoned, and a new developer took it over and injected some malware into it, right? So every application using the top level dependency, which didn't have anything wrong with it, was suddenly subject to those decisions being made by a completely different group of people. And that's kind of the dark side to all of this automation, right? You've got all these applications being built on demand, continuous deployment, everything gets pulled in at build time, but without really a human set of eyes going, wait a minute, like that actually turns out to be malware. All of a sudden there's a crypto miner being pulled into my container. So what's needed? I mean, yes, we need better detection to identify those anomalies at runtime, but fundamentally, it still has to come back to the developer whose job it is to write the code to remediate, right? So how can we push it back through the pipeline as quickly as possible with the right information to make better decisions about what goes in?
right, and as a developer, I mean,
Yep, go ahead.
no,
Mike.
as a developer, I mean, I know none of us want to be putting out bad code. It's more just a question of education and making sure that they have the right tools to one, identify. I mean, the person unless they're a malicious actor internally, they don't want to be putting out bad code. They're trying the best they can. So yeah, having that education, having that information pushed back to them, you're going to make the developer handle application security. You have to give them those tools as well.
Well, and handle it at the time when that fix is as cheap as possible, right? Because a developer hates nothing more than rework, right? Having to redo something I've already done after the fact, after my sprint is over, when that thing should already be in production because the security tool didn't give me the right information at the right time. And that's what I think we're trying to pry apart, is that traditional tension between the engineering side of the house and the security side that fundamentally, I think up to now, have had very different incentives, right? What's a developer's incentive? It's velocity. I got to get my tickets cleared. I got to get my commits pushed up, my pipelines run, my releases out into production. If I'm not forced to stop and think about security, then I'm not going to, right? Because that's somebody else's job. But that actually leads to worse outcomes overall, because then I'm pulling late nights, then I'm working out of band asynchronously to try and shoehorn the security in after the fact, rather than being armed with the information I need to build it in as part of the process from the beginning. And everybody wins. Security wins as well when developers are empowered, because then all that low-hanging fruit is dealt with early. That allows your runtime tools to work better, because they're not finding stuff that the developer should have seen way back in their IDE. Because it's like real obvious, not only what the problem is, but what's the solution.
It's really funny because I'm thinking of like the blast radius. When you mention cost, people immediately go to money. But now you're talking time, you're talking schedules, you're talking reputation, you're talking lines of business that are ruined because they have to deliver, certain capabilities on a certain time frame. All of that just proliferates out into multiple different groups, which gets us back to, trying to get all the groups to collaborate together for the shared focus of trying to deliver high quality software.
And not just expensive in terms of all of those things, but expensive in terms of risk as well, right? Like when do you want to find out that you've got an unencrypted S3 bucket, right? Do you want to find out when you've launched that bucket into production and you've scanned it with a runtime monitoring tool? Probably not, right? Because then it's already exposed to the world. You want to find out when you've written that CloudFormation template or that Terraform file and it's sitting in a Git PR, right? You want somebody to say, hey, we're not going to let this through the gate because we've identified that if you were to deploy this, here's the effect it would have. Oh, and by the way, we know how to fix this because it's easy, right? You add this little bit of YAML to your file and you're done. That's what we mean by closing that loop with the developer, because I mind that from an engineering perspective a lot less than I mind finding out 3 weeks later that I introduced the flaw into production and then having to burn the midnight oil to fix it. If I'm just getting that PR check warning or something popping up in my IDE, I'm thankful for that, because that lets me head off the problem when everything's in my context, right? It's directly in front of me. I see the solution. I cut and paste it, press the button, make a commit, and then I go on with my day.
That's a perfect segue into my next question with NIST, who's hard at work at developing compliance guidelines for software supply chain. But as we know, my concern is it's so comprehensive. I actually just downloaded the latest version of it. It's like 460 pages. It's immense because it has to be. But it includes infrastructure, like you mentioned, Clinton. And it might be just too daunting for agencies to adopt right out of the gate, which will leave them in a paralysis stage of trying to be compliant yet still trying to hit their commitments. What would be your advice to agencies looking to comply but not get so overwhelmed?
Yeah, that's a great point about including infrastructure. I think that that accurately recognizes the way applications are being packaged up now, and that's a good thing, right? It's moving in the right direction. What's interesting to me about a lot of these conversations is that they didn't start with the EO, right? The NIST has been working on these standards for software bill of materials for a number of years, and it's only now that the light is being shown. But it's great that that pre-work has been done, so that now we have an actual standard to wrap around and to discuss. What I would say is, first and foremost, you have to know what's going into your application, right, before you can begin to remediate. So do you have that bill of materials? Are you aware of each step in that software supply chain? And if not, I would say that's the obvious place, because if you, even from a kind of incident response perspective, don't know, say, how many of your applications are using a particular version of, say, OpenSSL, right? Or a very common dependency. You need that data to even begin to think about how you form a remediation plan. Right. So I think before going into gating and developer integration and education, all of that's really important. But you have to know what's in there first, I think, before kind of any of those things can come along as nice to haves. If you're going to start somewhere, start with getting the data, developing the tooling, and then kind of go from there into what preventive measures can we take moving forward.
Yeah, and that's what I like about the whole GitOps approach and putting the sort of that infrastructure element, those YAML files, into it as well, because then that, again, like you're saying, opens you up to being able to scan for best practices there and to say, hey, this is your infrastructure part. So that's bringing the dev, but it's also bringing the ops together, and that so that you can have automated security over all of it. I like that.
Well, yeah, I think it's important to recognize that none of these layers exist in a vacuum, right? And you can have, for example, you can have misconfigurations in your infrastructure that affect the blast radius of vulnerabilities in the application, right? If I've got a CVE in one of my packages in my container that's got a privilege escalation attack vector associated with it, and I'm running that container as root on my cluster, right? Like all of a sudden, that's a bigger risk because that attacker can then become root on the host. Right. But I only know that if I'm scanning both my container and my infrastructure vulnerabilities and combining the intelligence to say, actually, this is going to be a much higher remediation priority in this specific context than it otherwise would if I didn't have that additional information, right? So a lot of what we're doing currently is figuring out intelligent ways to combine those data sources together and do the research of figuring out what are the vulnerable conditions associated with some of these vulnerabilities, and then use that as part of an algorithm to say to a developer, hey, because we have this additional context, this should actually now be your number one remediation priority, because in a lot of these cases, there's an obvious known fix, right? It's either it's upgrading a package, it is changing a base image to a different OS, it's adding a line of YAML, right? The more we can front load that and show the effect, later on of combining all those layers of the stack together, then you start to get that education gear, kicked into place, and you start to create the instinctual ability to make better decisions earlier on. I think we're not quite there yet, right? I think we're not there with the detection, with the combination, with the intelligence. And I mean, industry wide. But as I would say, you got to start somewhere with the knowledge about what are the components, what are the ingredients in this food I'm about to ingest, and then go into, well, how are they all talking to each other, and what can I learn from that?
And so there is hope after all. We're working on it. We're getting there.
I hope so. Yeah, look, there's a lot of smart people working on these problems in industry and government. And I think the more we get together and have some of the difficult conversations about, hey, we got some catching up to do just on the conceptual level, and certainly at the technical level follows from that. I think everybody wins.
What I like about your company specifically, Clinton, is the risk score that you guys come up with, the quantitative amount, that now it takes that 5-page explanation about what the actual risk is down to a finite thing. So teams can get together. I'm talking devs, ops, networking engineers, security people, and you can have something to which to talk to. This is the score. You want to know more about it, we can dig down. But I like the way that now you can prioritize your attack on how you're going to remediate.
Absolutely, yeah. And I think it's key to get beyond the concept of severity as something that's like etched in stone. If you're looking at a list of vulnerabilities and all you're seeing is a traffic light, it's either green, yellow, or red. And the red ones are what I got to attack first, right? That doesn't take any of the application context into account. It doesn't take into account how those vulnerabilities are behaving in the real world. A lot of people don't know that. If you're looking at a CVSS, vector string, the severity that it's computed from is like that's purely theoretical, right? It's not like there are exploits in the wild that are being based on this. So yeah, to your point, I think what we try to do at Snyk is provide the other ends of that spectrum. Like, how do we think this is going to play in the context of your application based on all those things I was talking about, the vulnerable conditions, the reachability of certain vulnerabilities in your specific stack, how that combines with other layers of the technology, and then on the other end, how's that behaving in the real world? Are there known exploits? Is this something any script kiddie can download a shell script to fire off a bunch of attacks against your infrastructure? And is this something that's being talked about? Is there social media chatter around these vulnerabilities, which usually indicates that there are going to be attacks in the near future? So we combine all of that into that context-dependent priority score to say, for your application, for this specific integration, based on everything we know, this is going to be your biggest risk. And then, of course, give you the ability to modify that around the margins, right? To say things like, hey, this application doesn't actually have outbound network access, so all of these vulnerabilities with a network attack vector don't apply. Automatically ignore them or reduce them in priority, so that you're ensuring you've got that right balance between velocity and security for a specific group of projects that fits your own kind of internal business or mission logic.
Yeah, context is everything. Okay, we normally wrap up these podcasts with a sort of a lighthearted question based on our ContinuousX title. If there's anything that you could have or do continuously, what would it be?
Great question. I had to think long and hard about this one. So I'm a big food guy, and I love going to the next new restaurant, getting the tasting menu and having kind of that experience. But what I don't like is having to stand in line, having to figure out what the best new places are. So what I would want would be like continuous food delivered in kind of a tasting menu style, one little bite at a time, that just kind of shows up at my door and tickles my taste buds, and I don't have to actually think about it or invest energy in the process. That's what I want.
I love that.
If there's a VC out there who's looking for a new idea, like that's what I would pay a subscription fee for.
It's an Uber Eats, but in a continuous model.
Continuous micro food delivery.
Food delivery.
That's the new way.
Wow.
Sort of like one of those conveyor belt places. What are those conveyor belt places?
Just the food floats right to my door. Yep.
Yeah, right to your door. I love it.
I think that's the best answer we've heard so far. So that'll about do it for this episode. We thank all you viewers for your time and attention. Thanks, Clinton, for the information you shared with us today, and as we continue to solve for X in the SDLC equation.
All right. Thanks, Rick. Thanks, Mike. Glad to do it.